Hello, Intro to Stats class. Today we are going to learn about matched pairs and block designs. The format you see in this video is a digital edition, a newer edition, and it's on your page number 164 from your textbook. All right. So in this chapter, we are going to first understand matched pair, and what do we mean by matched pair here is basically when we conduct any experiment in order to compare two treatments or compare two things, we basically try to have the subjects as close as similar to each other as much we can do them. So here we have to choose pairs of the subject that are closely matched as possible. All right, so it's the comparison of two treatments, compares just two treatments in this kind of design. You have two treatments comparison, and after that when you do that, basically you choose pairs of subject, like the people you're conducting the experiment on, that are as closely similar to each other. So they should be exactly same, and then you try to conduct the experiment so that it avoids the variation in subjects. It avoids variation in subjects. So your subjects are almost similar, so you can then our comparison of the treatments would be fair. All right, but sometimes what happens, that is, instead of two subjects, they have sometimes just the matched pair, it may have just one subject. So just one person you're just comparing the treatment, like you're trying something. So instead of two people, you just pick one person for that. You have one subject who gets both treatment and other group. So you see that one subject gets both treatments. All right, so in order to, and this is done so that we can have exactly same person for both experiments, and we can reduce the variability. But how to assign the treatment to the person, like in which order, if we are having two experiments, so which order to assign so that they are not influenced, or their responses are not influenced by the order. That's done by randomization. So random assignment is random assignment of the treatments is done. So if they have two treatments, they can either they can toss a coin or something, so that they can assign which treatment the person is tested for first and then second one. All right, so let's move to the next part. Here they're just talking about a very good example 6.16, and that example in your book is example 3.17. Example 3.17. This is on page number 166. All right, it's about Coke versus Pepsi. So you will now understand why we are trying to have a matched pair design. Why? Because maybe if I'm having two group of people, and one person's favorite is Pepsi, other one's is Coke. So if I'm just conducting the experiment, they will be having their biased results, like they will have their biased opinion. So in order to remove that, we need to have the we need to have the matched pair. For that, here we will be a person who is going to be tested for both for the matched pair, and so we'll have one subject instead of two subjects. We'll have just one subject which is going to be tested for both. It's going to be tested for Coke and Pepsi. And what they have done, they have just marked the name, so they have just given a name here. So for that, the Coke, they have the Coke here, and the Pepsi. So Coke was named as Q, and Pepsi was marked at M. All right. So they have something like that, and the same person, the person didn't know which one is that, and the person was given both drinks, and this was repeated with several subjects, and after that they found out that Pepsi was, the conclusion was that a lot of people, more than the result said that most of the people, they preferred Pepsi. All right, so here could be one thing, the tasting experiment may be affected by the order of tasting or the chosen at random for each subject, which subject get the, so it is basically about which one gets the Coke first or who gets the Pepsi first. Maybe if you have a taste in your mouth and then you take another drink, maybe change the taste of second drink. So these are so many things working in the background, maybe affecting the result. So they have two names for, again I'm repeating that for Pepsi they have marked M, and for Coke they marked Q, and later on people said that that they preferred Pepsi because they like letter M. So maybe people are having different, because the reason they were just judging because people liked letter M. People liked letter M. So in order to have less variation and just to have a fair and biased result, sometimes it's really hard. So this is just one example for the for your same kind of subjects, for your another thing which is called block design. And what it is, basically block design, what happens, let's discuss that on next page. So block design is what? Block design is basically based on a principle where you have a group of experimental subjects that are known before the experiment. All right, you know them before the experiment, and they're supposed to be similar in some way. All right, block design. So very first thing, they're known, their group of subjects known before, and they're known before. If they're known before, the other thing what it is, that they are supposed to be similar in some way. They're supposed to be similar in some way, like you're just checking the age, ethnicity, gender, similar in some way, so that when you conduct an experiment, they're not giving you varied out responses. They must have the same, almost same kind of fair one. So in order to have the less variation in the response, and that kind of group is called block, and that kind of design is the block design. All right, so it's, and what happens, the random assignment is done within each group. So assignment of treatment is done randomly. Assignment of treatment is done randomly. So you have a randomization too, and the same time a group where you're matching the subjects in terms of specific qualities, so your response variable is affected less. All right, so let's move to another example for block design. That's example 6.17, and in your book, that is your example 3.17. This is on page number 166, and that's men, women, and advertising. All right, so here what they're talking about, that there is some kind of advertisement. All right, and how the men and women, they respond to different advertisement. So advertisement, where the basic goal of this study is to compare effectiveness of 3 television commercial. So in order to do that, we can take the help of completely randomized design or block design. So one case, if I just take completely randomized design, I can just consider them, men and women, just as a single pool. We are not going to differentiate between them, that this group belongs to men and women. Irrespective of their gender, we are going to randomly assign the different advertisement, and then we'll read the response variable. But sometimes what happens, the better way for that is, the better design for this is basically, if we compare men and women separately, because the way they have their liking for different advertisement could be different. So what we're going to do, instead of having a single pool, we're not picking a single pool here, we're just having them assign the different advertisement in different groups, 2 different groups, and the subjects are basically the men and women. They are here, these are men and women. But what we did, instead of having one pool, we're going to differentiate, make 2 groups. One belongs to women and other is men. So why? Because so that we have matched pair. All the women, they're, in terms of gender, they're same here, and men, it's very similar group. And then within each group, we're going to do random assignment here. Random assignment is done between the women and the men here. We have 3 advertisements, so we can pick the advertisement. Group 1, group 2 gets the first ad, group 2 gets the second ad, group 3 gets the third ad. And how this is assigned? By random assignment. Same thing for men. Group 1 is first ad, group 2 second, and group 3 is third. And then we can compare between the 3 treatments for the 3 advertisements for the women. Same thing, we can compare the response for 3 advertisement for the men. All right, so in this case, what happens, it's sometimes the block design, it is very similar to your stratified sampling. Okay, it's very similar to stratified sampling. There we have stratas, and here we have blocks or group. They're just similar to some kind of with some kind of property, and then we assign different treatments to them by randomization, and it has some kind of benefits. And what are the benefits here? Their advantages of block designs. Advantages of block design. The advantages are the same like our stratified random sampling. Like, first advantage is that it allows us to draw separate conclusion about each blocks. Like your previous example, you can conclude about the women and men, how they give their response toward 3 different advertisement. And the second one, here you have second, so this is the very first, that you can draw separate conclusion, and it also allows you more precise overall conclusion. All right, so it allows you precise overall conclusion, allows overall conclusion which is more precise. More precise. More precise. All right, so that's all about block design and matched pairs. And if you have any question, leave it in the comment box or loop mail me. Thank you so much.